Hello, my screen is visible to you. Hello, Kosik. Kosik Paul.
Yes, sir.
Okay. Siri, Siri.
Yes, sir.
Okay, okay. Okay, just I am starting. Okay, this is the live tutorial classes on manufacturing processes and casting and joining. Today, this is an extra class. Obviously, that includes a numerical number of MCQ questions that is very, very important and frequently came in the previous competitive examinations like junior engineer, uh, SSC, and railway engineering, and different competitive examinations. Okay. Basically, I have divided into two category. Casting. First, I will discuss some MCQ from the casting part. Then I will discuss from joining. Basically, joining means that whatever the course is designed here, that only uh, part is covered from the joining part is the welding section. Okay. Myself Subrata Kumar Maiti. Okay. PhD students from IIT Roorkee. Starting the live tutorial classes. Okay. First, first I will first questions. Just you have to answer and you have to practice this type of questions such that you will be comfortable for the upcoming examinations. It's maybe your NPTEL examinations or maybe your different semester course examinations or maybe other governmental job examination, competitive examinations. Okay. First questions here. Which one of the following is a permanent mold casting process? The questions is here, that is the permanent mold casting process. Uh, can you answer it? That is the investment casting process, fooled mold process, vacuum casting process, and die casting process. The short note is here. Okay, you can follow the note. There are basically two types of casting. One is the temporary casting. Already you have studied all the things. I have elaborated all the part. Two part categorized. One is the temporary molding, and second one is the permanent molding. Okay, and broadly you can say another one. It is the continuous casting process. Basically, continuous casting process. What type of material, what type of part can we design from the continuous casting process? Do you know? Kosik? Continuous casting process means as it as the name says that it is very continuous. It is continuous. Continuous means obviously our final product will be very long. That's why its name is the continuous process. It's like the example of continuous casting process, a railway track or five. Okay, different long section five. Okay, but our questions here from the permanent mold, which one is the permanent molding process? That is the investment casting process. Yeah, investment casting process is not the permanent casting process. Already I discussed. You can follow the old lecture. Full mold casting process is also not. Okay, vacuum casting process. Do you know the vacuum casting process? Vacuum casting process, like this is the injection molding process. Whether you want to produce any kind of bottle, okay, cold drink bottle or water bottle, these kinds of cold drink bottle and water bottle will can be produced from the by using the process of the vacuum casting process. Okay, but here according to the questions, answer will be die casting process. Okay, you just remember, and you remember the classifications of the casting, temporary mold process and the permanent mold process, and what casting process or molding process will fall under which category. Okay, okay. The next question is the injection molding is the ideal method for processing injection molding process. Okay, one is the plastic, thermoplastic, thermosetting, non-ferrous material. Okay, which one will be the correct options? Injection molding process. Injection molding process, that means some of the liquid material will be injected to a particular shape or to a particular die. Okay, suppose this is a particular die. Suppose I am drawing one bottle like structure. Okay, this is supporting part. Okay, and or by the using of syringe like process machine, you can inject the material on which material you want to flow inside the, suppose you want to make one bottle. Okay, you want to make chair. Okay, plastic chair. Okay, these types of liquid plastic will be pressurized into these kinds of die. Okay, this is die or mold, you can say. Okay, when the liquid molten plastic will flow and go into the inside the mold cavity, and it will make it form. Okay, shape, it will take it shape. Okay, these kinds of process is the injection molding process. Basically plastic like material can be produced or can be processed by using the injection molding process, plastic material. Okay, okay. Next question is, in order to generate a casting with an internal surface, which part is typically used in a casting operation? Internal part. I mean, if you want, you know the casting, for preparing any casting, for finalizing any casting, first of all, you have to make the pattern. Okay. But if the pattern is very simple, then you can easily produce one pattern, and using the pattern you can make one mold cavity inside the sand. This is called sand mold cavity. Okay, but if some arrangement like material you want to produce, that inside this internal something you need to prepare, then you have to go for the core. Okay, so core is used for preparing the internal surface, basically, which is typically used in the casting operation, that is called the core. Already it is also discussed in the previous lecture. Okay, you can see, you can read the about the core. Okay, core are used to get the internal cavity in the casting. Okay, already I discuss how the core is used. Okay, if you have any problem or if you have any doubts, you can ask me. I will give the example. Already I have given the example how the core is set uh, during the sand mold casting. Okay, okay. In which casting operations is an expandable pattern used? Expandable pattern: centrifugal casting, slash casting, and squeeze casting, investment casting. Do you have any idea? Expandable pattern is used. Expandable. Do you have any idea?
Sir, centrifugal casting.
Why?
Centrifugal casting.
Why it is like this? Expandable pattern is used. In any idea? Just you guess. Expandable casting means that it is kind of large, kind of long. Okay, can be extendable. Yes, your answer is correct. Correct. Centrifugal casting. That obviously on centrifugal force is there, and material is centrifugal casting. In the centrifugal casting, which type of material we can produce? Like hollow pipe. Okay, hollow pipe. Okay, so our answer will be centrifugal casting. In the centrifugal casting method, core is used. Sand, no, or ferrous or non-ferrous. In the centrifugal casting, core is used. Hello, this is very simple question. In the centrifugal casting, is there any core can be used for making hollow pipe? For making hollow pipe, okay. Generally, we use the centrifugal casting, but internal hollow. Generally, the students think that the internal hollow part, for making the internal hollow part, we will go for the core, but in the centrifugal casting there will be no core is used. So our answer is the no core. Okay, it automatically when it rotates, okay, when it rotates, the material will come to the surface, okay, and it automatically produce inside the hollow. Okay, hollow sections will automatically produce inside it. Okay, so our answer is no. No core is used actually. Okay, the hot chamber die casting method is used to cast brass, both brass and aluminium, alloy of lead, tin, and zinc. Okay, what will be the answer? Okay, here option 4. Okay, option 4 is our answer. Okay, and read the die casting. Die casting is a modeling process in which molten metal is injected under high pressure and velocity into a split mold die. Okay, obviously the die casting process requires high temperature and velocity. Material will flow inside the mold. Okay, hot chamber and cold chamber, their die casting is categorized into two types, basically hot chamber and cold chamber. Okay, metal like zinc, tin, lead, alloy are cast in the hot chamber die casting. Okay, you just remember these kinds of material is used for the hot die casting process. Okay, which one of the following casting process produce the product with a better surface finish? This is a better surface finish. Sand casting, hot die casting, investment casting, cold die casting. Which will be our answer? This is very important questions.
Sir, investment casting.
Investment casting. This is the right answer. Okay. Okay. The chief uh, advantage of die casting is possibilities of incorporating thick sections in small casting. Casting of insert is possible. Wide tolerance are possible. High production rate are possible. Okay. Die casting. What is the main advantages of the die casting? The main advantages of the die casting already I discussed in the classes. Okay, just you go through the previous class or previous note. Okay, and this just you read the previous note and try to solve, try to connect these questions. Okay, advantages of the die casting: good grain structure, low scrap rate, good surface finish, better appearance, high dimensional accuracy, repeated use of mold. The main advantages of the die casting is the rapid production rate. Okay, so high production rate are possible. Okay, because die casting is a permanent mold casting process or temporary mold casting process. That's why most of the permanent mold casting process generally there the high production rate are possible in that case permanent mold casting process, because sand mold casting process is a temporary mold casting process, because you have to prepare the sand mold cavity, then you have to break, and for further productions you have to again prepare the sand mold cavity, then you go for the another production. But here die casting process is the continue sorry die casting process is the permanent casting. Okay, the mold is like not make of made of sand, it is made of the metallic mold is used in the die casting process. So metallic mold, that the mold cannot be broken. Okay, it can be, the productions can be continuous, so high productions rate are possible. It is very very important. Okay, important. Okay, next, blow molding process to produce objects such as bottle. Okay, floatable object can be applied to only thermosetting plastic, thermoplastic, laminated plastic, reinforced plastic. Which options will be correct?
Thermosetting plastic.
Blow molding process. What is the difference between the thermosetting and thermoplastic? Your answer is correct. But tell me the difference between the thermosetting and thermoplastic. Do you know? Thermosetting plastic and thermoplastic. Thermosetting plastic, that is when there are different plastic like PVC and nylon, polyethylene. When you suppose this is the polyethylene, okay, polyethylene means carry bag. Okay, whatever the carry bag you used, generally they are made of the polyethylene. Okay, plastic. Okay, carry for the cloth. When you buy the cloth, they give you the carry bag. When you buy vegetables, they give you the bag, plastic bag. This is called the polyethylene material. Okay, when you melt this polyethylene, okay, this will melt. Okay, and if you give it to a particular shape like this rectangular shape, it will form this rectangular shape. Okay, but when you, and again you will give the heat. Okay, it will, it can be reformed, it can be reshaped. This is called the thermoplastic. But for the thermosetting plastic, it is one time you can give the shape. Okay, next time you cannot. So our answer will be thermoplastic. Clear? Okay, ornament 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 are cast by continuous casting process? Obviously no. Slash casting process, die casting process, centrifugal casting process. Which options will obviously continuous, not continuous casting process? Pipe, hollow pipe can be made. Die casting process, very large productions, it is not so much accurate. Okay, a centrifugal casting process, it is also kind of longer sections pipe. So slash casting is used for making ornament. Okay, so our option 2 is the correct option. The material of the pattern in the case of investment casting is used very simple. No thermosetting resin. Okay. Special plastic, no. Synthetic sand, no. Obviously wax. Okay. Is it clear? You know the process of the investment casting process. Okay, already it is discussed. Okay. You, before appearing the examinations, NPTEL examinations, you read all the class note. Okay, maximum questions will come from this class note and these kinds of MCQ questions. Okay.
सर
Okay, हाँ, tell me.
मैं पूछ रहा था हम लोग जो असाइनमेंट सबमिट किया है एनपीटीएल में
Okay,
वो असाइनमेंट पढ़ना जरूरी है क्या नहीं?
हाँ, all the MCQ questions, all the assignment. Okay, all read all the assignment, all the notes I am giving to you. Okay, and all the lecture. Okay, basically all the lecture series, whatever Professor Kumar Choudhury, okay, is delivered to you, that note I have prepared and I have uploaded into the Google Drive. You just read this note, or you may, if you have any confusions, you may read or you may go through the video lecture, okay, of Professor Kumar Choudhury. Also, you can go through my lecture. Okay, video lecture. Okay, but here today I am discussing some questions that is very important. Okay, these kinds of questions generally come in your examinations or any competitive examinations. Some questions you cannot find out from the note. That type of questions also I am discussing here, like these questions. Okay, these questions, some database questions is not mentioned previously, but these type of database questions may come in your examinations. Okay, so you have to, you should be prepared. Okay, you should be prepared for these kinds of questions. Okay, or you should be ready for tackle this type of questions. Okay, some questions you have to remember. Actually, suppose this is the question: in pressure die casting, what is the minimum pressure that can be applied? Okay, this should be a remember type question. Okay, 50 kg per centimeter square, 60 kg per centimeter square, 70 and 80. This is actually 70 kg per centimeter square. Okay, this is the minimum. Okay, this is the minimum. Okay, minimum. Okay, and what is the maximum pressure in the die casting? Because you know that the in the die casting process, the pressure and the temperature is used. So how much pressure should be used? How much, what is the minimum pressure? Okay, requirement. Okay, if the pressure is very high, then your mold can be broken. If the minimum pressure, your product will not be the accurate shape and size. So there should be a minimum and maximum range. Okay. So maximum, what is the maximum pressure? Okay, for the die casting process, maximum pressure you have to remember, that is the 5000 kg per centimeter square generally. Okay, you have to remember these questions. Okay. Okay. Alloy of which of the following metal is not used for hot chamber die casting? Hot chamber die casting. Which options will be right option? Not used. Not used. Hot chamber die casting. What is the range of the hot chamber die casting? Temperature range? Do you know? It is not very large. Okay. It is not very large. For the very high range temperature, melting temperature, okay, we generally used which type of casting? Sand mold casting. Sand mold casting, like aluminium above 600 700 degrees centigrade, like steel, okay, 1000 degrees centigrade, 900 degrees centigrade. Okay, but here for the die casting temperature range is around 450 degrees centigrade, so little lower than the sand mold casting, so little lower. So which material is not used? We cannot use the iron. Iron has a melting temperature above than the larger than the 450 degree centigrade. What is the melting temperature of the iron? About 930 913 degree centigrade. Okay, 900 degree centigrade. So iron will be the correct option. Here is the not used. Iron is not used in the die casting process because for the die casting process temperature range is 450. Iron melting temperature is high than the 450, greater than the 450. Melting temperature is the 900,000 degree centigrade. Okay. Okay, that's why iron cannot be used in the hot chamber die casting process. Important, this type of question. Okay, these questions is very simple. The ability of molding sand to withstand the heat of melt without showing any sign of softening is called as strength, cohesiveness, refractoriness, and collapsibility and adhesiveness. Which options will be correct? The heat melting without showing any sign of softening. That is the temperature resisting property, temperature withstand property. Which one? This is very simple. You can answer it. Which one will be correct? Siri, which one will be correct? Hmm? Kaushik?
Adhesiveness.
No, adhesiveness means what? Like Fevikwik. Okay, Fevikwik, what is the role of the Fevikwik? For joining the two part. Okay, suppose your shoe has teared some portion. Okay, just using the Fevikwik you can make it together. Okay, this is the adhesive. Okay, you can add together of the different metal or different part you can add. Okay, suppose this is the wood and you are adding another any plastic using the adhesive like Fevikwik. Okay, you can add it together. This is not the, this is the temperature resisting property. Refractiveness, high refractive material is like sand is the very high refractiveness. Okay, sand can withstand high temperature. Okay, हाई टेम्परेचर में भी सैंड क्या होता है, कोई सॉफ्ट नहीं होता है, ठीक है, नरम नहीं हो जाता है, ठीक है। सैंड कैन बी, sand can withstand very high temperature, okay, above 200 degree centigrade, okay. Sand is a very high refractive resistance material, okay. A model of casting constructed to use for forming a mold in damp sand is called dam sand. Sand construction, pattern, cover, none of the above. Model of casting constructed to use forming a mold in dam sand is called as which? Dam sand? Pattern is no, cover is no, sand construction, none of the above. Okay, this is the none of the above. Okay, which of the following is not requirement of a good pattern? Which is not requirement? Not requirement. Okay, this is not requirement. Good pattern. Okay, it should be light in weight to handle easily. For good pattern, this is very good pattern, Kelly. This is good pattern. Just wait 1 minute. Okay. So this is required property. This is desired property for the good pattern. Okay. It should be smooth to make casting surface smooth. Okay. So it is for the good property. Okay. Good pattern. Okay. This is also good pattern. It should have low strength to break it and to remove casting easily. Should have low strength. A pattern that means wood pattern, it should not have low strength. It should be enough strength such that it can be come out from the sand mold cavity. So not required. This option is the correct option. Okay. So option C is the correct option. The pattern which are made in two or more pieces are called as solid pattern, split pattern, loose piece pattern, none of the above. What is the answer? More pieces are called. More pieces. It is very easy. Solid pattern, no. Split pattern, no. Loose piece pattern, okay. Two or more pieces, okay. This is a loose piece pattern. So our option loose piece pattern is the correct answer. This is very important. Match the following content of green sand in group 1 with their approximate percentage in group 2. Silica, clay, bentonite, coal dust, water. What is the percentage of this material is used to make the green sand? Okay, green sand. What is the water percentage of the green sand? Obviously 7 to 8 percentage. This is the water. Okay, You study the previous notes, class note. Okay. Silica. Silica means sand. Okay. What is the percentage of the silica? You know that 70 to 80%. Okay. That is the up to 75%. Okay. This is the silica. Silica means sand. Sand is high percentage. It is very easy. That high percentage silica, because sand, silica is sand. Okay. Sand mold casting, green sand mold casting, sand, green sand. Okay, this percentage is very high. Okay. Next is the coal dust or clay. Next is the clay. You have studied the clay. What is the clay percentage? This is the 5 to 10 percentage clay. Okay, 5 to 10 percentage clay. Clay. What is the percentage of the coal dust? Coal dust percentage. Okay, coal dust percentage. Sorry, the clay is 8 to 15 actually. Clay is little higher. This is the clay. Clay, and 5 to 10 percentage is the coal dust. This is the coal dust. Coal dust. Clay is little higher than the coal dust. It is similar to coal dust and clay, but you have to remember the green sand, first sand percentage is higher, then the clay percentage will come, then the coal dust percentage, then the bentonite is very less percentage. Bentonite 2 to 5 percentage bentonite. This is bentonite. Okay, this is very simple actually. Okay, bentonite. Okay, so our option will be, right option will be silica 1, silica high percentage 75 percentage silica 1E, 1E. Okay, and 2C, clay 2C. Okay, and 3B, bentonite 3B, very small percentage bentonite. 4A, coal dust 2 to 5, 4A coal dust, and 5D water. So our option A is the correct option. Okay, you just remember these type of questions. This is important. Which casting process has no size shape limit? It is important. Sand casting, cell mold casting, plaster mold casting, none of the above. Cell mold casting obviously have one cell. Okay, like this cell. Okay, it has specific size and shape. Okay, so it is not. Plaster molding casting, plaster mold casting, it has also shape and size. None of the. Sand mold casting, sand mold casting, you can prepare very large sand mold casting. Okay, a very big statue you can prepare with the sand mold casting. Okay, you just prepare a very bigger size sand cavity, then pour the molten metal into the sand cavity, it can be produced. So sand mold casting has no size and shape limit. I mean, you can extend, you can produce very large amount of the large size of the product. Okay, that is a sand casting. Right answer is the sand casting. Okay, sprue. Sprue in casting refer to gate, runner, riser, vertical passage. Gate is different thing, runner is also different thing. Okay, riser is also different. Vertical passage, that is the sprue. Sprue is the pouring basin, then the sprue will come. Sprue design you have studied. Okay, this is the sprue, vertical passage through which the molten material flow, and molten material flow through the runner and then the mold cavity, then the riser is used for the compensate the shrinkage allowance. Okay, so our answer will be the vertical passage. Is it clear? Hot chamber method of die casting. The melting pot is integral with die casting machine. The melting pot is separate from the die casting machine. The melting pot locations has nothing to do with such a classifications. High temperature and low pressure alloy are used. Obviously, hot chamber method means that there will be one the chamber, okay, in which the material can be melt, okay, or molten material will be there, okay. So melting pot should be integral with the die casting machines, then only the molten metal will come to the mold cavity, okay, or die casting process. So it is an integral part, okay. Hot chamber is an integral part, because we know that the die casting process, heating and heating and pressure both are used, okay. What is the maximum pressure and minimum pressure? I have already discussed, 70 and 5000 kg per centimeter square, okay. So option A is the correct answer. Okay, the dowels are wooden nails, box nail, wire nails, none of the above. These kinds of questions you will not get from the class note. You have to prepare actually, okay. You have to go through these kinds of questions, okay. If you prepare or if you practice lots of MCQ questions, then only you can answer this type of questions. No professor, no faculty will uh, teach what is the dowel, okay. Okay, so you have to go, or you have to prepare, you have to practice, okay. So this is the wooden nail, okay. This is the wooden nail. Some casting equipment is showing here, okay. You can see this is the cope, this is the drag, this is the similar, you can alternate, okay. Okay, this is the vent spike. What is the applications of the vent spike? Any one of you can say? What is the drop in, vent spike, wrapping iron, gate cutter, rammer, screw pins, okay, degassing tablets, okay, striking of bar, riddle. What is the function of the vent spike? Do you know? Vent spike, as the name suggests, that it is used for the vent, it is used for venting the gas bubble or air bubble, okay. So we have to make some pinhole type through the sand, such that during the casting at high temperature the generated gas bubble will come out, okay. So this is the drop pin. What is the function of the drop in? Do you know? This is important. What is the function of the drop in? Drop in. Drop in function. What is the function of the drop in? Suppose you are making the mold and you are placing the one pattern here, Okay, 1 minute. Okay, whatever we are discussing, that drop in. Okay, as the name suggests, this is the drop in. Suppose this is the sand. Okay, you are placing one pattern just to make the mold cavity. Okay, you have to finally you have to remove it. Okay, how you will remove it? By using the hand? No, you have to use by the using of the drop in. Okay, there is a drop in means there is a some thread is there. Okay, just you can put the thread inside the wooden pattern, and slowly you will move it out, and the mold cavity, I mean whole cavity will be created. Okay, this is the function of the drop in. Okay, rammer is, you know, very easy. Okay, just to ram the sand. Okay, all the things you know, I think, no. Screw pins, you know, just to making the placing the screw. Okay, inside the uh, sand. Okay, for making the screw. Okay, which of the following are typically made of sand, plaster, ceramics, and similar material, and generally are mixed with various binder? Permanent mold, expandable mold, composite mold, ceramic mold. Which options will be correct? Which one of the following are typically made of sand, plaster, ceramics, similar material, and generally are mixed with the various binder? Sand, plaster, ceramics, for making the, obviously, which kinds of mold? You cannot, when you will use the sand, plaster, ceramic, this will be the permanent mold. Okay, permanent mold or expandable mold or composite mold or ceramic mold. This is called the ceramic mold because this is also kind of permanent mold, not permanent mold. Okay, permanent mold use for very large number of the productions, but it is called the ceramic mold. The furnace used for making, used for melting cast iron in the foundry is blast furnace, muffle furnace, cupola furnace, or crucible. The common furnace used for the cupola furnace. Okay, for melting cast iron. In melting the cast iron, melting is considered to be important because it controls the quality of the casting. A wide range of furnaces are available in the melting. Pit furnace, open hearth furnace, rotary furnace, cupola furnace, electric arc furnace. The choice of the furnace is made based upon the amount and the type of metal and alloy to be melted. At which temperature it will melt, and the amount of the material you are going to melt. Basically, the foundry, the cupola furnace is used. Okay, blast furnace is very high production industry. They are used basically. Okay, this is important. Diatometer, dilatometer is used to find which of the following property of the molding sand, permeability, moisture content, hot strength, compactness. This is also important. Okay, you cannot find this type of questions or this type of notes in the previous classes. Okay, if you practice more questions like this, then only you can remember, or then only you can accustom with handle such type of question. Okay, so dilatometer is used to find the hot strength property of the molding sand. Okay, hot strength of the molding sand. Okay, hot strength of the molding sand means at at a elevated temperature the sand mold strength. So dilatometer is used to, okay, this is the dilatometer used in laboratory. Okay, pickling treatment is cleaning the casting with soda ash, dilute acid, compressed air and sand particle, and iron soot. Pickling is a treatment that clean the casting. That means during the casting process, after getting the final product, you have to clean the different dart particle. Okay, that particle, oxide particle, how the oxide particle will form, because due to the oxygen, atmospheric oxygen. Okay, the surface can be oxide, can be, it can be oxidative nature will may come. Okay, so just you use some acid, okay, dilute acid, and you clean the final product. Okay, so dilute acid is used generally to clean the treatment. This treatment is called the pickling treatment. Okay, what is the which type of dilute acid is used here? Dilute acid, just hydrochloric acid, H2SO4, okay, sulfuric acid is commonly used in the pickling treatment for several reasons. Chemical reactivity, because it is dilute. Why it is dilute? We can use the concentrated H2SO4 or HCl, because the concentrated H2SO4 or HCl may corrode the final product. So we will use the dilution of the acid by adding extra amount of the water to the raw acid. Okay, so you have to control the chemical reactivity, control reactions and efficiency. Okay, pickling treatment is a surface cleaning process, improve surface finishing and promoting adhesions. Okay, if the how it is promoting adhesions, if you clean the surface, we can, suppose we can, if we clean the oxide layer of the surface, then it, if we use some adhesive material like Fevicol, Fevikwik or any adhesive type material, if you want to fix it with another material, it will easily fixed with another material. If the oxide layer is there, it cannot be fixed. So before fixing anything, we have to clean the surface, then only we can fix. Okay, so this is the process. That's why we are using this pickling process for surface cleaning, improving surface finishing and promoting adhesion process. These basically, for these requirement of the three things, we use the pickling treatment by using the diluted acid. Okay, okay, which of the following is not a casting defect? Scar is a casting defect. Yes. Scab, it is also a casting defect. Yes. Hot tear, it is also a casting defect. Hot tear, but hot crack is not the casting defect. Is not a casting defect. So our answer will be the hot crack. Okay. I have given you the casting defect. Already I discussed the casting effect, but here according to positions, whether the defect is occurring at the surface, all the defects occurring at the surface, this is called the blow, scare, blister, drop, scab, penetrations, buckle. This is the surface defect. Internal defect, blowhole, porosity, pinhole, inclusions, draws. Visible defect, you can naked eye, you can visible. Was, rattle, swell, misran, cold shot, hot tear, shrinkage shift. This is the classifications according to the positions of the defect, whether the defect is occurring at the surface, whether the different defect is occurring at the internal defect or visible defect. This is the thing. Okay, so here our answer will be the hot cracks. You have to remember this chart. These misran, cold shot, hot tear, okay, blowhole, pinhole, inclusions, all I have discussed. Maximum all I have discussed. Okay, or you can, okay, next. The property by virtue of which sand mold is capable of withstanding high temperature of molten metal without fusing is known as the same questions again, that is the refractoriness. Okay, and cohesiveness, adhesiveness, porosity, you have to read. Okay, refractiveness means that the, okay, resisting the high temperature, already I discussed. Resisting the high temperature, refractoriness. Porosity, it is the permits the steam or permit the gas. Okay, okay, this is the pore. The pore permits the flow of gas, steam. This is the porosity. Okay, adhesiveness, adhering capability. Okay, this is the adhesiveness. Cohesiveness, cohesiveness is, okay, cohesiveness is the same material if the for the same material. This is the same material. Adhesiveness, they are different material, two different material. When you want to bind or bond together two different material, it is called adhesiveness. When the you want to make the same material like wood, you want to join another wood, this is the cohesiveness. How it is binding together. Okay, here the sand grain, the same sand grain, how it is binding together uh, with the another sand grain, it is called the cohesiveness. Plasticity, the flow property. Okay, okay, flow property is measured by the plasticity index. Okay, this is important for mounting several pattern at a time. Which of the following type of pattern is used? Combined pattern, loose piece pattern, sweep pattern, match plate pattern. Match plate pattern, several pattern at a time. Obviously not the combined pattern. Loose piece pattern, not the loose piece pattern. Maximum in the loose piece pattern, not several pattern. Okay, loose piece pattern, the part of the pattern actually. So you cannot say it is loose piece pattern. Sweep pattern, sweep pattern is a different. Match plate pattern, your answer will be match plate pattern. Okay, the pattern is the replica of casting to be formed with some modifications. These modifications are in the form of allowances. Okay, there are the different types of pattern. Okay, you should know all the different type of pattern. Just go through the all the different type of pattern. Some of the pattern I have discussed during the lecture, but some of the pattern you have to study or you can ask me. Okay. Next question, match the items in the first column to the functions in the second column. These kinds of questions generally come very important, and most of the time you mark the wrong answer. Okay, you choose the wrong answer. So be cautious when you will solve this kind of questions. Okay, if you practice more, then only you can understand, or then only you can, it will be okay. Sprue, you know the sprue, you know the riser, you know the gate, pouring basin, all the things you know. So sprue regulate the flow of molten metal into the mold cavity, feed the molten metal from the pouring basins, obviously feeds the molten metal from the pouring basin. Okay, so P2, this is the P. Riser, riser is act as a reservoir of the molten metal, this is the Q. Supply molten metal to compensate, sorry, act as a reservoir, supply the molten metal to compensate the liquid shrinkage. Pouring basins, there is a pouring basin. So you just sprue is fed the molten metal from the pouring basins. Okay, P is 2, P2. Okay, Q riser, riser is the supply molten metal due to the compressor of liquids, this is the Q, this is not, this is the Q. Q4, this is the Q4. Okay, gate, what is the gate? Pouring basins. You just see this type of confusion type of questions you have to prepare. Okay, sprue generally used, P2. Okay, P2. Okay, Q4, 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 Q4 हो गया. This is done, this is done. Act as a reservoir for molten metal, obviously. Pouring basins 3, S regulate the flow, S1. So this is the S1. Pouring basins regulate the flow, this is the S, and act as a reservoir, this is the gate, R3. Okay, you just read. Pouring basins act as a reservoir, pouring basins reservoir. Okay, this is the option. So during just when you face this type of questions, just be cautious. You have to match the option as well as you have to apply your own knowledge, then only you can solve. If you apply only your reading knowledge, you cannot solve this type of questions. Next questions. Which of the following is not a casting defect? Hot tear, casting defect; blowhole, casting defect; scab, casting defects. Obviously, decarburizations is not the casting defect. So our option is the decarburizations. Okay. During the giving the answer, you have to read all the option. Then only you can be sure. Okay. Sometimes you are observing that it is correct. It is correct. You are just making for these options, but it may not be. That's why you go through all the option. Okay. Which casting defect occur due to excessive moisture content in the molding sand? Excessive excessive water, excessive moisture. So excessive water means that the it will be porosity. It will be porosity will be not shrinkage, will be not blowholes. It is the right option. Inclusions also you have to study. Next options. It is blowhole, but inclusions is not. So our blowholes. How the blowholes? If there is the excessive moisture during the hot molten metal pouring, the moisture will go into evaporations, and these evaporations will the oxygen and hydrogen, and that means the gas, the vapor will come out and it will make hole. Okay, it can make the hole inside the casting. So blowhole is the right option. Casting process is preferred for parts having a few details, many details, no details, non-symmetric shape. Which one will be the right option? Casting process is preferred for parts having few details, many details, no details. Obviously, it will be the many details. No details, it is not significant. Many details. Okay. Next. Dash are the casting defect by improper shrinkage or hindered contraction. So, due to the temperature difference, this type of problem will come. Okay, hot tear, shift, soil, fins. This is not. This is different. Shift is different. Hot tear actually due to the as the name suggests, a hot tear means that there will be the temperature difference and improper shrinkage. One shrinkage rate is another. One shrinkage rate is this. So another shrinkage rate is the different. That's why the hot tear will come. So our option will be the hot tear. Okay. This figure you just keep remember. Okay. The part of getting which regulates the rate of pouring of molten metal in is pouring basins, runner, choke, ingot. Okay. This is the choke present here. It just control the flow. So choke can control the flow of the molten metal. Okay. Pouring basins, due to the gravity the molten material will come, but here the choke is there, it controls the flow of the molten metal. You have to remember these things. Runner, you know, this is the runner, this is the runner. Ingots, in which the this is called the ingots, through which the molten metal fall into the mold cavity, come into the mold cavity. This is the ingot. Riser compensate the during the shrinkage. Okay, all the things. So our options will be choke, flow control. Many MCQ I am trying to solve here. You just go through this MCQ as well as from your side you just go through. Okay. So again the uh, these kinds of questions: defect, pinhole, misran, coal shot, gas hole. Okay, this type of questions you have to taken the extra careful. Okay, so pinhole metal start freezing before reaching the furthest point in the cavity. This is called the misran. Okay, if the molten material start freezing before the reaching the mold cavity, it is called the misran. Misran means that the that the molten metal start freezing before the reaching to the molten metal. So B is 1. So B is 1. Okay, this is B. Just I am writing in bigger size. B is done. Okay, now pinholes interrupt a spherical shaped bubble, tiny blowholes occurring either at or just below the casting. Okay, this is the tiny blowhole. Okay, pinhole. This is the 3. So option A is the 3. Next is the Misran pinhole. Cold shot. Cold shot. Acha. Just I am matching the option B1. I mean B1, B1, A3, A3, C4. Obviously, the C will be the 4. Cold shot. What is the cold shot? Metal start freezing before reaching the center of casting for a casting with 2 gates at its 2 sides. Okay, this is the cold shot. Gas hole. Gas hole means that the interrupt spherical shaped bubble. Okay, this is the gas hole. Okay, very similar kinds of things, gas hole and pinhole. Okay, but very tiny hole, it is called pinhole. Gas hole bigger. This is the gas hole. Gas hole is bigger. Okay, the option is very close. You have to think, you have to uh, read all the option very carefully. This is very small. Small is the pinhole, bigger is the gas hole. Okay, so our option 3 is the correct option. Are you getting me? Are you getting all the questions answer? The casting defect, which is produced because of displacement of the sand by the liquid metal at the wall region due to the hydrostatic pressure, is known as the mold shift or scab. Soil scab, run out or drop more than none of the above. Which one? You just comment this question in my YouTube video. Which one will be the correct option? I will not answer. You just read all the questions. Mold shift, it is not the mold shift, obviously. It will be no. Scrap, run out, drop, it is also not. More than no. It may be soil. It is soil actually. Okay. And other what the mold shift, you just comment in my YouTube video link. Okay. This, look at the photo picture. There is the casting defect. Defect is here. This is the casting defect. Is this misran? Cold shot, hot tear, shrink cavity. Mishran is no the Mishran. Cold shot no. Shrink cavity no. It is the hot tear. Tear. Hot tear means that the temperature difference. Okay, the temperature difference. The shrinkage rate is difference. Somewhere it is the hot and cold. Suppose the glass plate, you have the glass plate. If you hot this glass plate in this end and this is the cold, automatically it will crack, tear. This is the hot crack. It is due to the temperature difference. Okay. The defect in the casting due to improper ramming, soil, blowholes, drop, dart, improper running, improper ramming. Okay. So the previous, just you see, because of the displacement of the sand by the liquid metal, displacement of the sand, soil, the same questions, the defect in the casting due to improper ramming. You are getting that how the similar type of questions, but the in the different form. Okay, this is the soil. Soil is generally due to the when the mold is not properly rammed or rammed sufficiently, or was it is not rammed sufficiently. Suppose this is your one, this is your sand, you are ramming, you are ramming. Okay, if you do less ram, what will happen? The this mold, when you pour the molten metal, this molten metal, or this some portions of the molten, some portion of the cavity will be, some cavity maybe cavity size will be higher, cavity size will go start increasing. Okay, so this is the shift of the cavity. Okay, this is the soil is the answer actually. Okay, you read all the questions: soil, blowholes, drop, dart. Okay, Sobinov rules for calculating the solidification time for volume of a casting is proportional to, this is very simple, volume divided by surface area. So our options, A will be the right option. Okay, this is the numerical, a very simple numerical. Already I have given you number of numerical on the Sobinov rules. Yet I am going to solve the, what the Sobinov rule says, that solidification time, the time solidifications. Okay, time solidifications equals to volume of the casting. Okay, volume of the casting divided by area, surface area. It is whole to the power 2. Actually whole to the power n, generally we take n equals to 2. So for the molten metal radius 3, this is the spherical shape. There are two, this is the R1 is 3 millimeter and R2 is the 7 mm radius. Another spherical ball, this is the 3 and this is the 7. Okay, two ball are there. For the 3 mm radius, the solidification time TS1 equals to 12 second. You have to find out the TS2. It is very simple. What is the time TS2? Okay, so So what is the formula of the TS? Solidification time. TS equals to volume divided by surface area. What is the volume of the spherical ball? 4 by 3 pi R1 R cube divided by surface area 4 pi R square. So if you calculate TS, all will be cut, pi will go out. This is R by 3, R by 3. So we can say that TS1 divided by TS2 equals to R1 divided by 3 to the, sorry, it is to the power 2 square. Okay, so this is the square divided by TS2, it will be the 3 divided by R2 square. We can say that 3 cancel out, it will be the R1 divided by R2 square. Okay, so the TS1 is given and TS2 you have to find out. Okay, so TS2 will be TS1 multiply R2 divided by R1 whole to the power 2. TS1 it is 12 second, 12 multiply R2 means 12, sorry, R2 means 7 mm divided by 3 mm square. You calculate this one, you will find out the answer. Okay, next I am coming to the welding portion. Already this classifications you know, I discussed these classifications, I am given to you, again I am giving to you the classifications. Okay, you just study what is the classifications of welding classifications: solid state, liquid state, and mix is the soldering brazing. Okay, and cold welding, solid state, explosion welding, pressure welding, ultrasonic welding, forge welding, friction welding, diffusion welding, resistance under resistance welding, spot welding, projection welding, seam welding. Okay, liquid state welding, this is important, liquid state welding. Okay, two chemical reactions welding and arc welding. Okay, under arc welding AC welding or DC welding, plasma state, submerged arc welding, atomic hydrogen welding, renat gas, TIG or MIG. Okay, under chemical.
हेलो सर।
हाँ, हेलो.
सर प्रीवियस जो क्वेश्चन था उसमें TS1 कहाँ से आया?
TS1 is given actually 12 second. हाँ, ये 12 सेकंड गिवन है ना. R1 3 mm radius and TS1 is given 12 second. You have to find out the TS2. Understand? Clear? Is it clear? Hmm. So first questions from welding match the following: welding of aluminium alloy, ship building, joining of SSS drill, deep penetration precision weld. What will be the answer? Shipbuilding. Shipbuilding. For the shipbuilding, generally we use the submerged arc welding. You remember submerged arc welding, shipbuilding. So B1, there are the two options is there. Okay, welding of aluminium. Welding of aluminium, it is the TIG welding. A5, A5. So A5, welding of aluminium, A5. Okay, deep penetration precision. Deep penetration precisions, obviously. Deep penetration precision, D. Electron beam welding. Electron beam welding, it is a precision welding. Okay, and electron beam is a deep welding. This is friction welding, joining of SSS drill. So our option B is correct. You read all the option, otherwise it will be confusion. Sometimes it goes wrong. Okay, so read all the option, you correct, then go for the option. Okay, next is very important questions. Consider the following process. These type of questions, you will, if you solve this type of questions, you will be more confident. Okay, not you just read the notes, not you just you go for the lecture. Okay, you have to solve the questions, then only you will be more confident to give the answer. Otherwise it will be difficult and it may sometime confuse you. Okay, so this, read the questions very carefully. What the questions is asking here, consider the following process. The process is welding, different welding process: gas welding, thermite welding, arc welding, resistance welding. Okay, thermite welding, you know that it is a chemical process. Okay, arc welding and gas welding, you know that this is a liquid state welding, and resistance welding is a solid state welding. But you just memorize all the things, then come to the questions. The correct sequence of this process in increasing order of their welding temperature. What is the welding temperature of the gas welding? You remember oxyacetyl in gas welding? I told you 3100, 3200, 3300. Almost it is around 3300. Okay, you just remember. What is the thermite welding temperature? Thermite welding temperature is little lower, like 27 to 2800. Okay, 2700 to 2800 or 3000, I mean 3000. Okay, okay. Resistance welding, you just rub the two material. Okay, fixing one material. So resistance welding has a less temperature. It is generally at welding will done at around 2500 degrees centigrade. Okay, and arc welding obviously should be very high temperature. The arc will be generated and all the workpiece and electrode will be melted. Okay, so arc will be high temperature. It is around 700 degrees centigrade or 5000 degrees centigrade, 7000 or 5000 degrees centigrade, above than the 5000 degrees centigrade. So correct sequence of this process in increasing order of their welding. So increasing order means the three will come last, and then one will come, then 2, okay, then first is the 4. So option D is the correct. So high temperature required for welding, that process is called the arc welding. Low temperature is required, that is the most lowest temperature required, soldering and brazing. Okay, that is you cannot say this is welding actually. Okay, but here the according to the option, the uh, resistance welding, because it is solid state welding, the metal will not molted here. This is solid state welding, solid state welding na. And thermite welding, it is also liquid state, but you can say it as solid, semi solid and liquid. Okay, but this is properly gas welding and arc welding, it is the liquid state welding. Okay, okay, the strength of a properly weld joint as compared to base metal would be same, more, less, unpredictable. What is the answer? Obviously, the strength of properly weld joint as compared to the base metal will be more high. Okay, so option will be, sorry, this option will be correct option, more. So you just can you remember these things, that if I want to join two seat, the this is the welded portion, this is the welded portion, and this is the heat affected zone. You just remember, this is the heat affected zone, heat affected zone, and this is the welded zone, and this is the base metal or parent metal. Okay, all the grain structure I have discussed. You just see the grain structure. Okay, and how the grain structure will vary, the columnar grain structure, fine grain structure, coarse grain structure. I have you have studied already. Okay, which one is the this is the weld zone. Weld zone has a high strength than the base material, and heat affected zone has a very low strength. Okay, so, and base metal is the medium kind of strength. So what is the weakest zone? If I ask you one question, what is the weakest portion of a welded joint? So answer will be heat affected zone has the weakest portion, or is the weakest portion of welding. Okay, so the strength of heat affected zone, most weakest portion, heat affected zone, is heat affected zone most weakest. High मतलब strength, according to high strength, GTH strength is higher, most higher is the welded zone portion, weld zone. Medium is the base metal. So the strength is higher for the welded zone, then the base metal, then the heat affected zone. Heat affected has the less strength. Okay, it is very important questions. I can form this one questions like this. If I just rearrange the thing, strength according to the strength, I can make one questions. Okay, you just remember these things. Consider the following welded processes: TIG welding, submerged arc welding, electrode slag welding, thermite welding. Which of the following welding process are used for welding thick pieces of metal? Okay, thick pieces of metal. You know that TIG welding is used for the thin metal. Okay, like aluminium, thin metal. This is the thin metal. very thin metal. Okay. Submerged arc welding, it is generally 75 material sheet you want to weld, then thickness is around 75 Thermit welding, you know that the used for the railway track joining. Thermit welding, the hardly the railway track, it is a 100 to 200, I mean 200 that means 20 centimeter. Okay, 20 centimeter you can 20 centimeter or 250 25 centimeter. Or electrode slag welding, it has the highest thickness that can weld. Okay, 400 to 800 So thick pieces, which of these welding processes are used for the welding the thick pieces? Thick pieces, so if I consider the thick pieces, so first three will come, I mean thick, this is the three. Okay, then what is the question? Thick pieces of the metal, which of the following weld processes are used for welding thick pieces of the metal? Okay. Thick pieces of the metal, that is a TIG will not be the answer. Okay, so option 2, 3 and 4, 2, 3, 4, this is the correct option. Okay, this is the correct option. Okay, except the TIG welding, all the welding process are used for the thick sheet of the metal, thick sheet for welding. Next, DC generator set is used in submerged arc welding, TIG welding, both the above, none of the above. We can use the AC or DC. Okay, DC generator is used for submerged arc welding. For the submerged arc welding, both we can use AC or DC. For the TIG welding, we can use the AC or DC both. Okay. So our option both the above. Okay. Read the next question. Huh. So following equipment is used for arc welding a material by carbon electrode. Carbon electrode, which of the following welding process? Which of the arc welding material is used? AC welding set, refractor, motor, generator, DC welding set with straight polarity. These are very interesting questions. As the carbon electrode like tungsten electrode, carbon electrode is used, is the similar. Okay, tungsten electrode or carbon electrode. Obviously, the carbon electrode and tungsten electrode, for the case of the carbon electrode and tungsten electrode, we generally prefer the less heat produced to the electrode. Okay, less heat produced in the electrode, that is the non-consumable electrode. Non-consumable electrode is used, that means non-consumable electrode. Non-consumable electrode. You just remember the step, how I am solving these questions. Okay, non-consumable electrode. For the case of the TIG, suppose TIG, non-consumable electrode is used. So less heat is produced in the electrode. So higher heat is produced in the workpiece. So higher HIGH, higher
हेलो
heat.
सर।
Yes.
सर प्रीवियस क्वेश्चन में बोथ कैसे होगा?
DC generator set is used in submerged arc welding and TIG welding. Okay. DC generator we can use for the both TIG and submerged. Anything you can use. Okay. I will explain. I will explain. Just after this I am explaining. Okay. After this questions I am explaining. Higher heat generation at the workpiece. Higher heat at workpiece. Okay. So higher heat at the workpiece means that when the workpiece is positive, then the higher heat will be generated. So workpiece is positive. So DC DC reverse polarity, for the DC reverse polarity, for the DC reverse polarity, for the DC reverse polarity, higher heat at the workpiece. Hmm. Sorry, higher heat. Sorry, this is the not reverse polarity. It is straight polarity actually. The workpiece is positive. The workpiece is positive and the electrode is negative. The electrode is negative and workpiece is positive. This is the straight polarity. DC current with straight polarity, or DC current with straight polarity, or DC current with the electrode negative. Electrode negative. Okay. For this case, the high heat produced at the workpiece, high heat. What is the percentage of the heat produced in the workpiece? I discussed. High heat. Do you remember? 2 by 3 portion of the heat is produced at the workpiece and 1/3 heat is produced at the electrode and 2/3 is the workpiece. So our option will be the DC welding set with straight polarity. Okay. Okay. I am discussing these questions. Basically, what happened? You just remember these things. DC current, there are the two polarity basically. There are the three polarity. DC current, straight polarity. Another one is the DC current. Kaushik, are you listening me? Are you getting me? Kaushik, who is asking the questions? Why the both of the above? Okay, just I am remembering these things is important actually. A DC current state polarity means that the DC current electrode negative. DC current reverse polarity means that the DC current electrode positive. AC is the AC. So heat at workpiece, heat at workpiece will be the higher for the straight polarity. 2/3 heat, 2/3 portion. This is the 1/3 portion, and this is the 50%. 50% means that the 1 by 2, or you can say 1 by 2 percentage. If you consider the percentage, 33. This is the 67%. Okay. So according to our desire, when the workpiece is thicker, then you have to use the DC current state polarity. When the workpiece is thin, then you have to use the DC current with the reverse polarity. When the medium kind of things or thin kind of thing, for the TIG, AC TIG, we can use. Okay. Oh, actually, we can use both AC and DC for the welding. Okay. This is why we can use both. We can use. Which welding set have higher initial cost? DC generator set, motor generator set, AC generator set, none of the above. Obviously, the AC is only one set is there. DC generator set is high cost because you have to add the generator and again you have to the current voltage is transformer, all the things. So DC generator says is the higher initial cost. Welding goggles used during the welding joint chipping, gas welding. Obviously, it is the both. Which one of the following control welding current and voltage? Welding set, earth clamp, welding cable, all of the above. Current voltage regulating means the one box. When you if you saw the welding, one is the box is there and one uh, if you this is the welding you want to weld it, one clamp is clamping to the welding portion or clamp, negative clamp, I mean earth connection is there, and this is the one electrode, this is the electrode, it is welding. So welding set current voltage, this is the welding set controls the current voltage. What is the use of the flux in the welding process? Remove oxide of the metal formed at the high temperature, permit the perfect cohesion of the metal, both of the above and none of the above. So flux, the why the flux is used? Flux is used to coat the welding portions to remove the oxide formations. This is the okay, and also the cohesions of the metal because it contains lots of different metal such that the welding strength is high. So both it is correct option. The main criteria for selection the electrode diameter in the arc welding is a material to be weld, type of the welding process, thickness of the material. Thickness of the material is important. According to the thickness of the material, we have to use the electrode or diameter. Okay, first the thickness of the material, then the electrode material you have to choose, then the current voltage you have to fixed. Okay, then the voltage you have to fixed. Okay, the electrode used in the arc welding are coated. This is not expected. Which one is not expected? The not expected thing is the provide protective atmosphere to the weld, stabilize the arc, and allowing element, prevent electrode from the contaminate. The electrode, coated electrode obviously provide the protective atmosphere to the weld, stabilize the arc obviously. Okay, how the protective atmosphere to the weld? It can protect the atmosphere, it can protect by the two process. One is the shielding of the gas, another one is the shielding by the slag formations. Okay, and stabilize the arc, it is okay. Alloying the material because it contains lot of different alloy like tin, lead, okay, tungsten, chromium. Okay, these type of metal is used to strengthen the welding portions. They prevent the electrode from the contamination, it is not. So our option is the D. So not expected to. So correct option is the D. This is a not expected. You just read it carefully. So this is all about the casting and welding MCQ. You have to remember, you have to study such type of MCQ questions. Then only you can solve different questions. And already I have solved number of the numerical questions. If you solve these kinds of numerical questions, whatever I prepared in the earlier lecture, earlier live classes, if you solve this type of numerical questions, you can attend any kind of examinations, starting from the gate to state junior engineer level questions. Okay, and I have discussed almost uh, above
Sir,
60-70 questions, MCQ questions. You read the MCQ questions and also you read the extra MCQ questions from the book or internet. Yes.
सर इस पीडीएफ को हम लोग ड्राइव में डाल देना थोड़ा सा।
हाँ हाँ हाँ, वो डाल देंगे, उसमें तो
और
कोई
और क्या हम लोगों का क्या और क्लास होगा, लाइव क्लासेस?
लाइव क्लासेस आई थिंक और नहीं होगा, ठीक है।
और हम लोग तो एनपीटीईएल जो एग्जाम देंगे उसके
हाँ,
लिए बेसिकली किस किस टॉपिक में ध्यान देना पड़ेगा?
किस किस टॉपिक में ध्यान देना पड़ेगा, जो जो हम लोग पढ़ाया हूँ, ठीक है, मैं जो लाइव
लाइक
लेक्चर लिया हूँ वो
हाँ
सब, जो मैं नोट्स भेजा हूँ,
हाँ।
प्रोफेसर सोनक कुमार चौधरी जो जो पढ़ाया है वही ये लाइव क्लास, वो जो क्लासेस है उसको अच्छे से फॉलो करना है, नोट्स
अच्छा
पढ़ना है, दिस एमसीक्यू अच्छा से पढ़ना है, न्यूमेरिकल प्रैक्टिस करना है, और तुम एक्स्ट्रा भी कुछ एमसीक्यू पढ़ के गो फॉर द एग्जाम, यू विल गेट above 90%.
ओके सर,
Okay,
थैंक यू।
all lots of material you have. Okay, you just go through this material, you will get nine. I would say that 90% questions will come if you read all the questions carefully, or all the notes. All the best. I am expecting that all of you who have attended, all of you will score good marks above 90 percentile. Okay, all the best for your examinations. Okay, and for your future career. If you have asked any questions, I am ready to answer. Yes. Hello.